Welcome to our deep dive into the intricacies of creating animations in Premium HMI. Today, we're tackling a common challenge faced by many users, the limitations of animation capabilities within this platform. Specifically, we're looking at how to animate objects like rectangles and circles based on variable thresholds and logical expressions. Imagine you want to change the color of a rectangle based on a variable's value, say green for values up to 1, yellow up to 2, and red beyond that. While this seems straightforward, the real complexity arises when you want to incorporate logical expressions, such as beta and bit or bic. Understanding these limitations is crucial because it directly impacts the interactivity and responsiveness of your HMI. And here's why that matters: mastering these animations can significantly enhance the user experience and operational efficiency of your machine interface. Understanding the theoretical basis of HMI animations is crucial for effective implementation. At its core, an HMI animation is a visual representation of a process or data change. Imagine a rectangle that changes color based on temperature readings. This is achieved by linking the visual element to a variable that represents temperature. The system evaluates the variable's value and applies predefined rules to change the visual properties. For instance, if the temperature is below 20 degrees Celsius, the rectangle might be blue. Between 20 and 40 degrees, it turns green, and above 40 degrees, it turns red. These rules are often set using threshold values. But there's more. Advanced animations can involve complex logic, such as bitwise operations. For example, you might want an object to change color only if certain bits within a variable are set. This is where the var bit syntax comes into play. By understanding and utilizing this syntax, you can create more dynamic and responsive HMI animations. Now, let's dive into the initial configuration for basic animations. Imagine you're setting up a simple threshold-based animation. You'll start by selecting the object you want to animate, such as a rectangle or a circle. Next, you'll navigate to the Properties panel where you'll find the animation settings. Here, you'll set up your thresholds. For example, if you want the color to change from green to yellow at a value of 1, and from yellow to red at a value of 2, you'll input these values directly into the threshold fields. Remember, the key to a smooth animation is precise threshold setting. This ensures that the transitions are seamless and visually appealing. And here's why that matters: precise thresholds not only enhance the visual feedback but also improve the overall user experience by providing clear and immediate responses to variable changes. Now, let's delve into the heart of implementing complex logic in your animations. Imagine you're working with a human-machine interface, or HMI, and you need to animate objects based on intricate conditions. You've got your basic threshold animations down. But what if you need to use logical expressions like beta and bit or bic? Here's the exact method: access the bit of a variable using the syntax var bit. To create an expression, you'll combine these bits using logical operators. For instance, if beta and bit are both true, or if bic is true, your animation will trigger. This is crucial for advanced HMI functionality. Remember, the key is to understand the syntax and the logical flow. If your software supports it, you can directly input these expressions into the animation settings. If not, you might need to use an instruction list, or EL, similar to AWL and Siemens, to achieve the desired logic. This approach gives you the flexibility to create animations that respond to complex real-world conditions. Now, let's dive into advanced techniques and optimization strategies for your animations. Imagine you're working with complex logic, like combining multiple bits to trigger an animation. The trick is to use logical operators. For instance, if you want to change the color of a rectangle based on multiple conditions, you can write an expression like this: var 00001 and var 00002, or var 00003. This means the animation will trigger if both var 00001 and var 00002 are true, or if var 00003 is true. To optimize, ensure your expressions are as concise as possible. Avoid redundant checks and use efficient logical constructs. Remember, every millisecond counts in real-time applications. And here's why that matters. Efficient animations not only look smoother but also reduce the computational load on your HMI, allowing it to handle more tasks simultaneously. Now, let's dive into the common pitfalls and debugging tips for your animations. One frequent issue is setting incorrect thresholds for color changes. Ensure your thresholds are logical and cover the entire range of your variable. Another pitfall is misunderstanding the syntax for bitwise operations. Remember, for bitwise use and for or, use or. If your animations aren't triggering as expected, double-check your logic expressions. A common mistake is forgetting to update the animation conditions after modifying the logic. Also, be aware of version limitations. If a feature isn't working, it might be due to your software version. Lastly, use the troubleshooting flowchart I've provided to systematically identify and resolve issues. This will save you time and frustration. To master HMI animations, remember the core principles we've discussed. First, understand the limitations of your HMI software. If direct expression writing isn't supported, utilize alternative logic like YIL. Set thresholds for color changes meticulously, ensuring each state is clearly defined. For complex animations, break down the logic into manageable parts. Use bitwise operations to create intricate conditions. Remember, the key to successful animations is in the details. Each parameter, each value, must be precisely set. And here's why that matters. Precision in setup leads to reliability and performance. This leads us to our final point. Always test your animations under various conditions to ensure they behave as expected. By following these steps, you'll not only enhance your HMI but also deepen your understanding of animation techniques. This is the kind of in-depth knowledge that others charge for, but here, it's yours for free. If you found this valuable, consider subscribing for more deep dives into critical tech topics.